Hello, you are welcome to Zion Tutor, where we make mathematics, physics and further maths question that looks difficult, more simpler and more easy for students to comprehend. Now today in our teaching, we want to teach a topic that says polynomial. And when we are talking about polynomial means that if you have an expression in this form, ax cubed plus bx squared plus cx plus d equals to 0. If you check this expression, the highest power of the unknown variable in this expression is 3. So we can refer to this expression as a polynomial. Also, if we have the highest power to be 4, like this ax cubed plus bax raised to the power 4 plus bx raised to the power 3 plus cx squared plus dx plus e equals 0. The highest power of the unknown variable here is 4. We can also refer to it as a polynomial. So if you have a polynomial, what are the things we need to know in polynomial that will enable us to solve any question? If you see this topic polynomial, it's both in the WAEC curriculum and also in the Cambridge curriculum, and the way they set their questions seems similar in those two curriculum. So if you have a polynomial in this form, how do we solve it? Because the power of the unknown variable here is 3, that means this polynomial we have a 3 solution. Don't forget from our quadratic equation that we have something like ax squared plus bx plus c equals 0. When we find the solution of this kind of expression, at the end we later have what we call our x1 is equal to, maybe let me say p, and also our x2 will be equals to q. Why do we have 2 solutions? Because the power of the unknown variable here is 2. So that means if you are solving for this, that means the solution of this equation has to be what? 3, because the power of the unknown variable here is 3. Also, if you are solving for this, since the power of the unknown variable here is 4, the highest power is 4, that means we have a 4 solution to this kind of equation. So one way to solve this is by doing a factor method. Now if you have a solution, if you are given that the solution of a polynomial are, let me say, we have it as p, q, and r. What they are just saying here is that your x is equals to p, or your x is equals to q, or your x is equals to r. Now from what we learned from quadratic equation, if I want to combine it, to be x minus p equals to 0, or x minus q equals to 0, or x minus r is equals to 0. So if I want to combine the 3, it will be in this form as x minus p, x minus q, and x minus r is equals to 0. And when we expand this, we will find out that the power, the highest power of the unknown variable here will be the power of what? 3, when we multiply this thing out. So what I'm trying to establish here is that if you have the solution of your polynomial, you can form that polynomial that gives you this solution. Or if you have a polynomial like this and you're asked to solve it, that means you can solve it through a factor method. That means you try to factor that polynomial. For example, let me say, for example, if you have a polynomial that says, you're in a x squared plus 5x plus 6 equals 0. Don't let me put 0. If you have a polynomial like this, you can factor this as in form of x squared plus 3x plus 2x plus 6. That now begins to do like this. That means you have x into bracket x plus 3 plus 2 into bracket x plus 3. That means we have x plus 2, x plus 3. So this is a factor form of this polynomial. So that means what they are saying, if the owner wants to find the solution of this polynomial, that means if I say x plus 2 equals to 0 or x plus 3 equals to 0, that means my x here will be minus 2 or x will be minus 3. What this thing is giving us is that if you put 2 into this equation will give us 0. Or if you put minus 2 rather to this equation, it will give us 0. And if you put minus 3 to this equation, it will give us 0. That is the idea we use if we have a polynomial that have more than, that the power of that polynomial is more than 2. If you are given a polynomial that is, maybe it has x cubed or x raised to the power 4, let me say we have something like x cubed plus 3x squared plus 2x plus 1 equals to 0. How we factorize this is, we need to find a number, either positive or negative. Now when we substitute it to this equation, it will give us 0. Like this now. Now if we can find a number that we substitute to this polynomial to give us 0, that means we can factor that polynomial. And we start from here. We start from something like x equals to minus. So that means if minus 2 will work, that if we substitute minus 2 into this equation and it gives us 0, that means we can also find another number that when we substitute it, it will give us 0. And that method will try to lead us to what we call a factor theorem. And this theorem is very important in our polynomial. If you want to solve any polynomial question, we call it a factor, or what we call a remainder theorem. What is this theorem saying? It says that if you have a polynomial, let me say that polynomial p of s. If you have a polynomial p of s and x minus a is a factor of polynomial p of x. Now if x minus a is a factor of this polynomial p of x, so what they are trying to say is, if I turn this my p of x to 0 polynomial, that means x minus a equals 0. That means my x will be equals to a. What is saying that since my x is equals to a, so if I come to that polynomial p of, now my x is equals to a, p of a will be equals to 0. That means if I substitute 0, I'll be a into that polynomial of p of x, I will get 0. What that thing is telling me that x minus a is a factor of this polynomial. X minus a is a factor of this polynomial. Or in other way they said it is that x minus a, p of x, that means the polynomial p of x is divisible by x minus a. Let me bring out to our normal arithmetic. If you have 16 over 4, 15 over 4 is 4. That means 4 can go in 16 without leaving any remainder. That's why we have 4. Now if you have something like 8 over 3, 3 cannot go in 8 without leaving any remainder. That means this one will be 2 whole number, 2 over 3. So this ideology now, let's use it in this polynomial. Now, if x minus a is a factor of a polynomial, and I change x minus a to 0 polynomial, that means x becomes a. If I substitute s into that polynomial p of x, into this polynomial p of x, and at the end I arrive at p of a equals to 0, what I'm saying that p of x is divisible by x minus a. That means we have a 0 remainder. That means here, the remainder here will be equals to 0. But in a situation whereby we substitute s equals to a like this, and the polynomial does not arrive, we don't get 0 at the end of this polynomial, that means the remainder, what is left there, is what we call the remainder. If we substitute a into this polynomial, and at the end when we do our calculation, we don't arrive at 0. That value that we arrive at is what we call the remainder of that polynomial. So this factor theorem is very useful when we are solving our polynomial. The combination of your factor theorem and the zero polynomial, what we do here is what we call zero polynomial. So it's a combination of the two. Now from this little explanation, let's solve a question. The question is from IGCSE 2022. It's IGCSE 2022, and the question is saying this. It's saying that the polynomial equals to 6x cubed plus ax squared plus 6x plus b, where a and b are integer and p of s is by 2x minus 1, full stop. When p of s is divided by x minus 2, the remainder is 120. The first question under this is find the value of a and b, and the second question under is saying write down the remainder when p of x is divided by x. So look at this question. I think it's IGCSE 2022. It's IGCSE 2022. It's May, June paper 2. Now look at this question. We are given that a polynomial. This is a polynomial, but the polynomial will be constant a and b, where a and b is integer, and that polynomial is divisible. It's divisible by 2x minus 1. The word divisible by 2x minus 1 and divided here, they are two different things. What they are saying here is when this polynomial is divided by 2x minus 1, it leaves no remainder because it's divisible. It's like the what I said the other time, that 16 over 4 equals to 4. It's divided without leaving any remainder. That means what they are saying here, the remainder is 0 when 2 of x is divided by this polynomial. And also they are now told that when p of x is divided by this, the remainder is this. We are now told to find a and b. Now the first thing to do here is first bring out our polynomial, which is 6x cubed plus ax squared plus 6s plus b. These are polynomial. The first thing we are told here that p of x is divisible by this. Is divisible by 2x minus 1. If we take 2x minus 1 to 0 polynomial, we say it's equals to 0. That means 2x will be equals to 1, and that means my x will be equals to half. What I'm saying that if I substitute, that means my p half, since the word divisible by this, the remainder will give me 0. That means if I substitute half into this polynomial as x, I will equate it to 0. That means it has to give me 0 because of this word that says it's divisible by 2x minus 1. So that means p into bracket half will be equals to 0. What does that mean? Let's substitute half into this polynomial. That means I'm saying 6 into bracket 1 over 2 raised to power 3 plus a into bracket 1 over 2 square plus 6 into bracket 1 over 2 plus b will be equals to what? 0. Since that statement says it is divisible by 2x minus 1. Now if you do this, we have 6 over 8 plus a over 4 plus 3 plus b equals 0. And we can simplify it further here. This is just 3 over 4 plus a over 4 plus 3 plus b equals 0. So to linearize this, I can just multiply through by 4. Multiply everything through by 4. So this will just be 3 plus a plus 12 plus 4b equals to 0. And a plus 4b will be equals to 3 plus 12 is 15. If we take it out, it becomes minus 15. This gives us an equation 1 from that question. And the second question is also saying that if p of x is divided by x minus 2, say it is divided p of x divided by x minus 2. The next thing we do the same thing here. We take x minus 2 to 0 polynomial. That means our x becomes 2. The same thing we do. That means in this polynomial we substitute x, but that one we are told that the remainder is equals to 120. That means in this one the remainder is not equals to 0. So let's substitute 2 into this polynomial. So that means we have 6 into bracket 2 raised to power 3 plus a into bracket 2 square plus 6 into bracket 2 plus b will be equals to 120. So if we substitute this, 2 raised to power 3, that's 8 times 6, 48, plus 4a plus 12 plus b will be equals to 120. So that means if we from there our 4a plus b plus 60 will be equals to 120. So from here we can get our equation 2 to be equals to, if we take 60 out, that means we have it to be equals to 60, equation 2. If you see the two equations now, we have a simultaneous equation to deal with. The first one is saying a plus 4b equals minus 15. That's our equation 1. And 4a plus b equals to 60. That's our equation 2. Now from here, we can use our elimination method, which is the fastest one. If we want to eliminate a here, we make sure that the coefficient of our a is the same. Now how do we do that? If we multiply equation 1 by 4, and we just leave the equation 2, or we say we multiply it by 1, just to retain what is there. So that means we have 4a plus 16b will be equals to minus 60. And to retain that, we still have 4a plus b will be equals to 60. Now from here now, since what we want to, the variable we want to eliminate have the same sign, we just make sure that we subtract it. And if you subtract 4 minus 4 give us 0, 16 minus b, 16b minus b will give us 15b, minus 60b minus 60, that will be minus 120. So we divide both sides by 15. So that means my b will be equals to minus 8. 120 divided by 15, that's minus 8. Since we know our b, we can use any of the two equations that says a plus 4b equals to minus 15. That means a plus 4b, if we substitute our 4 here, that will be 4 into bracket minus 8 will be equals to minus 15. That will be 4 minus 32 equals to minus 15. From here, you will see that our A equals to minus 15 plus 32, and that will give us 17. Now we have our A to be 17 and our B to be minus 8. I think that's the first part of that equation. So if our A is 17 and B is minus 8, let's form back the quadratic, the polynomial. So that means our polynomial will just be 6x cubed plus, now our A is, this will be 17x squared plus 6s. Now our B is minus 8. So this is the polynomial P of x. Now if you go to the part B of that question, it's saying that write down the remainder when P of x, now our P of x, which is this, is divided, that's the part B, by x. Now if we take x to 0 polynomial, what we just have there is x will be equals to 0. So that means if we substitute x equals to 0, the number that we get, the value that we get will be our remainder in that thing. Now that means, let me say P of 0 will now, because if I substitute 0 here, 6 into bracket 0 cube plus 17 into bracket 0 square plus 6 into bracket 0 minus 8. So that means my P of 0 will be equals to minus 8. That means the remainder of that polynomial is minus 8. That was the first example in this topic. The remainder is minus 8. Now the second example that looks like this is also IGCSE question. The question is saying the roots of P of x equals 0, where P of x equals, let me put it here, where P of x equals 5x cubed plus ax squared plus bx minus 2 are x equals to 1 over 5, x equals to n, and x equals to n plus 1, where a and b are positive integer and n is a negative integer. Now say find P of x. Find P of x simplifying your coefficients. SE 06 06 2022 is February March 2022, and this question 5B. Now if you follow this question properly, we are given that the three roots of P of x are, that means the first root are saying x equals to 1 over 5. The second root is x equals to n. and the third root is s equals to n plus 1. And we are given the polynomial, this polynomial. And also we are given the root. So that means from the root of this polynomial, we can form back this polynomial. Since we have been given the roots, we can form back the polynomial, but there is a condition that is there. We are told that where a and b are positive integer, that means the value for this a and b is positive. And that the value for our n is a negative integer. So how do we go about this? But since we have been given the root of this polynomial, that means they have solved the polynomial. They have come out that the first root of the polynomial is x equals to 1 over 5. The second root is s equals to n. And the third root is s equals to n plus 1. So how do I form my polynomial from these three roots? And I will just compare it with the polynomial given. So what is here is we say x equals to 1 over 5, or x equals to n, or x equals to n plus 1. So this, what we have is this 5x minus 1 equals to 0, or x minus n equals to 0, or x minus in the bracket n plus 1 equals to 0. So if I combine the three, so that means the polynomial p of x will becomes 5x minus 1 into bracket x minus n, and the third one x minus n plus 1 equals, okay, you can say this equals to 0. Now this is the polynomial by using the root of the equation to form this. Now if you look at the polynomial given, if you check the polynomial given to us, this polynomial, in that polynomial we say p of s is equals to 0. In this polynomial, if you put x to be equals to 0, what do we arrive at? That means here, if x is equals to 0, this p of x, if you put 0 here, this becomes 0, this becomes 0, this becomes 0. That means our p of 0 is minus 2. The same thing, let's do it to the one that we form, that we look like this. That means we have 5x minus 1, x minus n, and x minus n plus 1 equals 0. That means if I put x to be equals to 0 here, what will I get? If I put x to be equals to 0, that means if x equals to 0 here, this will be left with minus 1 into bracket, this will be left with minus n into bracket, this will be left with minus n plus 1. So since this polynomial has this root, and the p of 0 of this one is equals to minus 2, that means the p of 0 of this one also has to give us what? Equals to minus 2. So minus 1 times minus n, that will give us n into bracket minus n plus 1, close the bracket, equals to minus 2. So if we check this, that means from this equation you can get the two possible values for our n. You can say your n equals to minus 2, or I can say minus into bracket n plus 1 equals to minus 2. So that means my n will be minus 2, or n plus 1 equals 2. From here my n will be equals to 1, and here my n equals to minus 2. But from our question, we have been told that n is a negative integer. So that means we disregard this because this is a positive integer. We now go with this. That means our n equals to minus 2. because it's a what? A negative integer. Now if our n is equals to minus 2, so it will be easier for us to form the quadratic equation using the root, since we now know the value for n. From here now, since my n equals to minus 2, that means that the quadratic equation I formed through the root of the equation given will just be 5x minus 1. What's my n? Is it minus 2? Sorry, that means n will be x plus 2. The third one will be, since that will be x, n is minus 2, minus 2 plus 1, that's minus 1, n plus 1. This will form my p of x, the polynomial. You see now, the polynomial is now in terms of x. So if I open this bracket, to know the highest power of my x, maybe we first deal with these first two. That will be 5x squared minus 10x minus x minus 2 into bracket s plus 1. That's our polynomial p of x. So if you, this will be 5x squared minus 11x minus 2 bracket s plus 1 equals to p of x. Now let's open this. This will be 5x cubed minus, this will be 5, this will be plus 10, sorry, plus 10x minus x minus 2. And here that means we have plus 9x minus 2. So that means 5x cubed plus 5x squared plus 9x squared plus 9x minus 2x minus 2 equals to polynomial p of x. That means 5x cubed plus 5x squared plus 9x squared, that will be 14x squared plus 2x, 9x minus 2x, that will become 7x minus 2 equals to what? Our polynomial p of x. Don't forget, we want to look for a and b. Now if you compare the polynomial this with the one given to us in the question that says 5x cubed plus ax squared plus bx minus 2. If you now check this thing, you see 5x cubed, ax squared, we check the coefficients. That means by comparing the coefficients, we arrive at our a equals to 14 and my b will be equals to 7. And don't forget, from the question, we are told that a, b are what? Positive integer. And you see the answer that we get here, our a is plus 14 and our b is also what? Plus 7, which makes them a positive integer. Please, if you find this teaching interesting, please don't forget to subscribe, like and share to people that you know that they will value these things. To every secondary school student or Cambridge student that are doing O level and A level. Thank you.